problem based on energy stored on a capacitor. In the figure given below, X, Y represent X and Y represent parallel plate capacitors having the same area of plates and the same distance of separation between them. What is the relation between the energies? What is the relation between the energies stored in the capacitors? Let me give you the figure also. We have two capacitors X and Y. Connected to SOs with say voltage some V volts. So this is capital V and this is X, Y. So here the dielectric is air. Air is the dielectric for this capacitance, and another has a dielectric medium with dielectric constant K is equal to 6 or epsilon R equal to 6. Epsilon R or K both are same, 6. First let us read this. In the figure given below, X and Y represent parallel plate capacitors having the same area of plates and the same distance of separation between them. What is the relation between the energy stored in the capacitors? We need to find out what is the relation between the energy stored in both the capacitors. So let us solve this. We'll write solution. First remember this thing. I'll write a note here. So when two capacitors are connected in series, the charge on each capacitor are same. Charge on each capacitor connected in series combination is same. Series combination as same. Also here it is given that these two plates have same parallel plates, plate area and the distance of separation, so they will have equal capacitance in the air or vacuum. Two capacitors having same plate area and an equal separation have equal capacitance in air or vacuum? Vacuum. Okay. So remember this, charge on each capacitor is same when they connected in series. Also, if capacitors have same area of plate and the equal separation between the plates, then their capacitance will be same in air or vacuum. Let A be the area of plates and D be the separation between the plates for X and Y, for capacitors X and Y. Then in air, the capacitance Cy is given by the capacitance Cy. The capacitance, sorry, so for Y it is air is the medium, dielectric medium, so it is epsilon naught A divided by D. Let A be the area of plates and D be the separation between the plates for capacitors X and Y we have taken. So Cy is epsilon naught A by D. Similarly, the capacitance Cx value Cx will be equal to epsilon naught epsilon r A divided by D, which is equal to epsilon r into, I can write epsilon naught A divided by D. Now we know epsilon r, it is given as 6. Epsilon r is 6. So this can be written as 6 and epsilon A by D is Cy. So we got the relation between Cx and Cy. Now we can easily get the relation between the energies. Now energy stored is given by energy stored in a capacitor as U is equal to Q square by 2C. Q square divided by because Cx Cy are connected in series, the charge is same, so I can write U is proportional to 1 by C, and from this we can write the energy stored in X will be proportional to 1 by Cx. Also energy stored in Y, Uy, is proportional to 1 by Cy. So let me call this equation as 1 This is 2. Now if I divide one by the other, equation 1 divided by equation 2 will give us ux by uy equal to cy by cx. And we know cx is 6cy. This is equal to cy divided by cx is 6cy equal to 1 by 6. So ux by uy is 1 by 6. Ux divided by uy equal to 1 by 6. Ux by uy is 1 by 6, or ux is 1 by 6 uy. Ux is 1 by 6 uy. This is the relation between the energy stored in X and Y.